Imagine the Earth's surface like a giant jigsaw puzzle, with each piece fitting perfectly into the next. It's not one solid piece, though. Instead, it's made up of many large and small pieces. This puzzle is made up of massive pieces called tectonic plates, which are like the Earth's outer shell. These plates are always on the move, but don't worry, they move very, very slowly. So slowly, in fact, that you wouldn't notice it happening. We're talking about a few centimeters a year, like how fast your fingernails grow. Imagine watching your fingernails grow. That's how slow these plates move. These plates float on a layer of hot molten rock deep inside the Earth, known as the mantle. This molten rock is constantly moving, causing the plates above to shift. Think of it like ice cubes floating in a punch bowl. Just as ice cubes drift on the surface of the liquid, tectonic plates float on the molten rock. These plates are the foundation of our continents and oceans. They carry the land masses and the ocean floors, shaping the Earth's surface. They shape our planet's surface and create some of its most dramatic features, like towering mountains, deep valleys, and vast ocean trenches. But their movement isn't always smooth. Sometimes the plates get stuck and build up pressure. Sometimes these plates bump into each other, move apart, or slide past one another. When they finally release, it can cause earthquakes or volcanic eruptions. And that's when things get really interesting. These movements can reshape the landscape in an instant, reminding us of the dynamic nature of our planet. Tectonic plates are constantly engaged in a slow, graceful dance. These massive slabs of Earth's lithosphere move imperceptibly, yet their movements shape the very surface of our planet. They move in different directions and at different speeds, creating a variety of interactions at their boundaries. These interactions are responsible for some of the most dramatic geological events on Earth. There are three main types of plate boundaries: divergent, convergent, and transform boundaries. Each type of boundary results in unique geological features and phenomena. At divergent boundaries, plates move apart from each other. This separation allows molten rock from beneath the Earth's crust to rise up. Molten rock from deep inside Earth rises up to fill the gap, creating new crust. This process is a continuous cycle of destruction and creation. Imagine two conveyor belts moving in opposite directions, adding new material to the surface. This is how new oceanic crust is formed. This process is happening right now in the middle of the Atlantic Ocean, where the North American and Eurasian plates are pulling apart. The Mid-Atlantic Ridge is a prime example of a divergent boundary. Convergent boundaries are where plates collide head-on. These collisions can be incredibly forceful and lead to significant geological changes. Imagine two cars crashing into each other. The energy released in such a collision is immense. The impact can be powerful. Earthquakes often occur at these boundaries, shaking the ground and sometimes causing widespread destruction. Sometimes one plate is forced under the other, back into the Earth's mantle. This process is known as subduction and is a key part of the plate tectonic cycle. This process is called subduction. It not only recycles the Earth's crust, but also contributes to volcanic activity. In other cases, the plates crumple up, creating towering mountain ranges. The Himalayas, for example, were formed by the collision of the Indian and Eurasian plates. Volcanic eruptions are another dramatic result of tectonic activity. These eruptions can create new landforms and alter the landscape dramatically. At transform boundaries, plates slide past each other horizontally. The San Andreas Fault in California is a well-known example of this type of boundary. These boundaries can also cause earthquakes as the plates grind against each other, releasing built-up stress. The dance of the plates is a slow but powerful force, constantly reshaping our planet. From the creation of new crust to the formation of mountains and the occurrence of earthquakes, tectonic activity is a fundamental aspect of Earth's dynamic nature. Transform boundaries are where plates slide past each other horizontally. These boundaries are one of the three main types of plate boundaries, the others being divergent and convergent boundaries. Think of rubbing your hands together. The friction you feel is similar to what happens when tectonic plates slide past each other. The friction can generate a lot of heat and pressure. This heat can sometimes be enough to melt rock, creating magma. This is what happens at transform boundaries, causing earthquakes along fault lines. These earthquakes can be minor tremors or devastating quakes that reshape the landscape. The San Andreas Fault in California is a famous example of a transform boundary. It stretches over 800 miles and is responsible for some of the most significant earthquakes in North American history. These plate movements have a profound impact on our planet's geography. They can create new landforms and alter existing ones, influencing ecosystems and human settlements. Over millions of years, continents have drifted across the globe, moving at a rate of a few centimeters per year. Oceans have opened and closed, creating new seabeds and submerging old ones. This process is known as seafloor spreading and subduction, and mountain ranges have risen and eroded. These geological processes are ongoing, constantly reshaping the Earth's surface and creating the dynamic planet we live on today.